In this video, we're going to solve some examples of indefinite integrals. So just to recap from the last video, we know that the integral capital F at x is equal to, or we write it in this way, so this sign here of f at x dx. So now let's say that our integrand, okay, the function that we're supposed to integrate, takes the form x to the power of r, so a polynomial. Then we know that the integral of f at x dx is equal to x to the power of r plus 1, the exponent plus 1, divided by r plus 1 plus c, some constant. So let's do an example here. Let's say we have a function called f at x. We'll do a very simple one to start off. So f at x is equal to 3. Now we can also look at this function as 3 times x to the 0, because anything to the power of 0 is just equal to 1, and this is 3 times 1. So the integral of that, okay, the integral of f at x dx, okay, we would just use this format. So remember, it does take this form here, okay, so we have something, get x to the power of something, and then times some coefficient. So let's go ahead and integrate that. So we have 3 times x to the power of 0 plus 1 divided by 0 plus 1, and then plus c. And of course, this gives us, so this will be a 1, so 3 times x to the power of 1 over 1, and which you can just simply write as 3 to the x. Sorry, and should not forget the plus c. 3 times x plus c. So that one's pretty straightforward. How about another one here? Let's say we have a function g at x. G at x. Oh, just gonna, yeah, give ourselves a little bit of extra space here. Okay, so g at x is equal to 5x squared plus 2x minus 1. Okay, what is the integral of that with respect to x? What is the integral of g at x dx? So using our rule again, we're going to raise that exponent for each of them. So we're going to go 5 times x to the power of 2 plus 1 over 2 plus 1. And then this would just continue down. So we're going to go 2 times x. Okay, so imagine there's a 1 here. Okay, there's an imaginary 1 there. So 2 times x plus 1 over 1 plus 1 minus 1. And remember, think of it being next to the power of 0 there. So times x to the power of 0 plus 1 over 0 plus 1, and then plus c. So when we simplify that, we get 5x cubed over 3 plus 2x squared over 2, in which these 2's cancel out. And then we have 1x to the power of 1 over 1, and of course these 1's cancel out, plus c. So you're just left with something that looks like this: 5x cubed over 3 plus x squared minus x plus c. So again, we have another pretty easy one. Okay, another pretty easy integration there. Okay, let's do another one. Let's do another one here. So we have a function, we'll call it g at x as well. G at x is equal to 5xh minus 3x squared minus 2. And then we're asked to find the integral g at x dx. Okay, so what would that be? So remember, the dx means that we're we're integrating with respect to x. Okay, so that means everything else we treat as a constant. So we would have, so the 5 and the h here, as you can see, would be treated as constant. So we'd go 5h, then x, then that's what we're going to raise the power to. Okay, so we know x squared, okay, because there's an imaginary 1 here, over 2 minus 3x cubed. We're going to raise the exponent and then divide by the exponent. And as you can see here, these 3's cancel out, minus 2x. And then I'm going to go plus c. So when we simplify that, we get 5hx squared over 2 minus x cubed minus 2x plus c. Alright, so there's a very, very easy one again. Now let's do one last example here. Let's do one last example. So let's say, okay, see that we're given a function h at x, we'll call it. H at x is equal to 5x to the power of 4 plus 6x squared. And we're asked to find, okay, we're asked to find the integral h at x, okay, capital H at x, where h at 1 is equal to 5. Okay, so again, the process would be the same. This is still a definite or an indefinite integral. So h at x, okay, so the integral of h at x dx is equal to, so we go 5x, and we're going to raise that exponent to a 5, divide by the exponent, okay, and then these would cancel out, plus 6x, I'm going to raise this exponent to a 3, and divide by that 3. And so this would simplify to x to the power of 5 plus, now 6 over 3 is 2, so 2x cubed. Okay, so now that's the first step. Now they've told us, okay, that h at 1 is equal to 5. So what this means is that when x is 1, okay, h at 1 is going to be equal to 5. So 5 is equal to, I'm going to use this formula here. 5 is equal to, and then we have x is 1, so 1 to the power of 5. And also what I should do is, before continuing, make sure I include my plus c right there. Okay, we're going to continue. Plus 2 times 1 to the power of 3 plus c. Okay, and this simplifies to 1 plus 2 plus c, giving us 3 plus c. Now if we want to find out what c is equal to, we have, we'll bring the 3 over, so we'll subtract 3 from both sides. That gives us 5 minus 3, which is equal to 2. So c is equal to 2. So that means our final answer, I'll use a different color here. Our final answer, h at x, is equal to x to the power of 5 plus 2x cubed plus 2. All right, and there you have it. So those are some examples of how to compute an indefinite integral. And in the next video, we're going to start talking about the definite integral.